Now that we know how diode works, let's see how we can use it to make a half-wave rectifier. And if you need a refresher, feel free to go back and watch the earlier videos. But let's start from the name. There are two parts, half-wave and a rectifier. Let's start by rectifier. What does it mean to rectify? So a rectifier basically is a machine which turns AC into DC. So it means turns AC or alternating current into DC, direct current. Okay. And let's make a refresher on what AC means. So AC or alternating current is a current that alternates with time. And if we plot it against, if we plot current or voltage against time, so it can be current or voltage. Okay, that means it's either one of them or it can be both. But for now, let's plot them. So, and that's if it follows a sinusoidal regime. So it basically looks like the graph y equals sine of x. Okay. And there are also other ACs, alternating currents, maybe like this, the blocks. But let's face it, they're not used. That's the majority. And now power comes in that waveform. So let's look at just it. Let's look just as it. Just at it. Okay, AC means it alternates between a positive value and a negative. So it crosses, let's make it 1 volt here. And minus 1 volt. So it crosses the 0 point and goes into the negative. That means alternate. But direct current, it's a bit different. Same graph here. Gains time. And what's direct current? So direct current means that it just stays in the, no, let's make it a bit different. Can change. Okay, it can change. It's possible. But it only stays in the positive region. Okay? It doesn't go in the negative region. It can change its values and not only the voltage of the current. But it only stays in the position, in the section it started. Let's make another DC, for example. Another graph. It's either one of them. And let's make it start from negative, because there is such thing as negative DC. Okay, let's make it this. But check it out. It doesn't go in the positive region. If it goes in the positive region, it means it's AC. So this may be minus 1 volt. That's AC. It can go into the negative and the positive values. It goes into negative and positive values. And that's DC. which only stays in the negative, or it only stays in the positive values. Okay, and a rectifier means it turns AC, which goes AC into DC. That's basically it. That means a rectifier. And the other half of the name, we'll see why it's called half wave. Okay, if we have an AC signal, let's make it only with voltage here. And it follows the pattern of y equals sine of x. So this time it means my S might jump. Sine of t. Okay, it's like y equals sine of x if you put it in GeoGebra. Oops. But here we replace the y with u and x with t, and you'll get the same plot. So if you want to turn this AC into DC, we need a rectifier. And we'll look at a half-wave rectifier using a diode. So this wave here plus a diode results in that kind of graph. And we'll see why later. Will result in that graph. It basically cuts off the negative region because the semiconductors don't allow current to flow into the negative parts. So okay, let me draw again the AC like this. So it basically destroys all of that current. It removes it. There is no negative region. In the negative region, the semiconductor is a isolator. No current will flow. And what you're left with is just the top region, okay? So I can remove all of that voltage here. Voila. Now you only have DC because it doesn't go into the negative region. Look, it will be 1 volt, it will be 0 volt, and down from here are the negative volts. And the diode has a kind of a wall here, which blocks the current when it goes in that direction. Because in AC, the current goes in this direction and the opposite. Because it goes from the positive. Okay, that's the positive. Connected here with plus. Here with minus. That's the top region. And if I draw again a diode for the bottom region, basically the ports, the poles will change. So this minus will go here, and the plus will go on the opposite side. And now, as we know, the current flows from the positive into the negative. So I flows from here, and this barrier doesn't allow it to flow. So we remove the negative part. That's the top. That's the top part of this graph, and that's the bottom. That's the bottom part. And we basically remove the bottom part. And what we are left with, let me draw it a bit cleaner. And that will look something like this. I'll leave the AC here. Well, I think you can figure out on your own. You can pause until I draw it and think about it, how it will look if we remove the bottom part. Voltage. And it will look something like this. Stop. No voltage. Again, it stops at the zero because the semiconductor turns into an isolator when the current reverses, or the voltage, okay, current, voltage, whatever, reverses positions. It goes into the negative. So no current here or voltage, and it goes up again, and it continues so on until infinity. And that's the graph of a half-wave rectifier. Have you seen why it's called half-wave? We're only left with the half-wave. Here we have a gap. Here we have nothing. So half of the wave has been removed. That's why it's called half-wave rectifier.